Hello friends, welcome back. Today's video is about OptaPlanner. In today's video, we'll be learning about OptaPlanner, and this video will be in two parts. On the first video, we'll be learning the theory part of OptaPlanner and we'll know how OptaPlanner works. In second part of the video, we'll be doing hands-on. We'll be writing a Spring Boot programming to implement OptaPlanner and we'll be testing that using Postman. So let's start. Course objectives, we'll be learning what is a OptaPlanner, types of problems it can solve, how OptaPlanner works, and the other two things, last two things we'll be doing in the second part of the video, that's hands-on implementation, and we'll be testing the solution with Postman. What is OptaPlanner? OptaPlanner is an open source AI constraint solver written in Java that helps you optimize planning and scheduling problems. Think of it as a smart engine that takes hard to solve problems and finds an efficient near optimal solution. Key points: purpose: solves optimization problems such as employee rostering, vehicle routing, task assignment, conference scheduling, exam timetabling, cloud optimization, etc. Core ideas: the problem constraints like a nurse cannot work 2 shifts in a row, the planning entities and variables like each nurse works which shift. How it works: it uses AI technique like heuristics, meta heuristics, and constraint satisfaction to efficiently search for solutions. Integration: this runs on a JVM, integrates well with Spring Boot, Quarks, and other Java ecosystems. For our example, we'll be using Spring Boot. License: it's open source license backed by Red Hat. Types of problems it solves: workforce and shift scheduling. Example, nurse rostering. So assign nurses to shifts respecting working time rules, skill requirements, and rest periods. For call center staffing, it can bring solutions by balance employee availability, skills, and workload. For factory workers, it can ensure coverage across machines and reduce overtime. Vehicle routing and logistics, delivery routing optimization, plan delivery truck routes with time windows, fuel limits, and capacities. Ride sharing, taxi dispatch, it can match drivers to riders while minimizing travel distances. Waste collection routes, it can optimize paths for garbage trucks to reduce costs. Apart from this, it can be used in many other scenarios like portfolio optimization for finance, call routing in telecommunications, staff vacation planning, car rental fleet assignments, etc. Now the main part, how OptaPlanner works. For this, we'll be consider one example like itinerary generation with OptaPlanner, and based on that, we'll be seeing how OptaPlanner works. So imagine you are building an app that generates a one-day sightseeing plan for a traveler in New York. So first we have to define the problems. How? So problem facts we have to provide like locations, what all places the visitors needs to visit, like museum, park, restaurant, etc., with coordinates and opening hours, so that we can understand the distance from one location to another location. So that's why we need the coordinates and opening hours, and basically we need the end closing hours as well, so we can understand that it won't overlap. Travel times, distance between locations, travelers preferences, like if the person wants to visit historical places, so we might can uh, prioritize the museum visit before than anything else. Planning entities, visit, that is a planning entity, a planned stop at a location. Each visit needs a planning variable like time slots, when to go. So time slots are telling that from when we are going and when we are finishing that one itinerary or one location. and possibly sequence and order. Solution class contains the list of locations, contains the list of visits, holds the score of the itinerary. We are continuing how OptaPlanner works for the same example. Next is constraints. Those are the rules for itinerary. So there must be some hard constraints which we cannot break, like opening hours must be respected. So if a museum is opening at 9 a.m., we cannot go there. We cannot schedule 8 a.m. visit there, right? That is a hard constraint. We have to be there after 9 a.m. No overlapping visits. So at a time we cannot visit two places, right? So that's what we have to respect. We cannot plan something which will overlap. Total itinerary fits within the day. So if we have three itineraries, we have to uh, fit in inside a day, means total hours at 9 a.m. to 6 p.m. We cannot fit more than three itineraries, three locations there. So that's how we have to make sure that total itinerary fits between the given time frame. So these are the hard constraints, examples of hard constraints. Now, some examples of soft constraints, right? Like minimize the total travel time. It can, we do not need exact minimized time, but we'll try to come up with a with a plan where we can minimize the total time travel. Prefers travelers interest, so we'll be try to keep that in mind, that okay, the person wants to visit museum, like he likes cultural places, so the persons will visit museum first, or will prioritize that. Schedule lunch for an hour at noon, so that is kind of a soft constraints which we try to maintain. Balance sightseeing with breaks. So these are the examples of soft constraints. So when we'll be seeing the examples, we'll be seeing them in details, these hard constraints and soft constraints, and how they are getting calculated. We are continuing uh, how OptaPlanner works for the same example. So initial solution, start with a simple plan. So how it will work? So initially it will start with a simple plan, but that plan may have lots of soft score. Then what it will do, it will automatically recalculate based on the score, and it will try to find with an optimal solution. So score calculation. So first it will create an initial solution, then it will calculate the scores. So how the scores will be calculated? This is an example. OptaPlanner evaluates the itinerary with the score system. Hard score. Hard score means number of violated must have rules. Means if a member has to have a lunch between 1 to 2, we cannot have a lunch at 5 o'clock, right? Means 5 p.m. If we plan that for 5 p.m., then there will be a violation of must have rule, that will cause a hard score. Soft score, like quality measure, like we can add -10 for each extra 10 minutes of travel time, means which we can stop, but because of our non-optimized plan, if we are adding extra time travel, then that will add a score. So this is the way it will calculate hard and soft score. So say after first iteration, the first solution is having one hard score, that's for late lunch, and then 120 soft score. So based on this, OptaPlanner will recalculate and try to find another optimal solution where we might be having 0 hard score and maybe 10 -10 soft score, right? So that will become an optimal plan, and then it will accept that optimal plan. We are again continuing that OptaPlanner, how OptaPlanner works. For the same example, we saw that initial plan and then optimization loop. So then OptaPlanner will reiterate and redo that, and it start tweaking the itinerary, change the itinerary, swap orders of visits, adjust time slots to reduce overlaps, try different lunch placement. All these things it will do, and it will again keep recalculate score. It will recalculate score and see the better, if the score is getting better. If the score is getting better, then it will keep that and again recalculate on top of that. And if next time the score is coming much better than that, then it will keep that and again recalculate on top of that. If it is not coming, it will keep the best score which it could achieve. I hope you understood this part. And for that it will use this meta heuristics methodology. So over thousands of iterations the plan improves. So based on this iteration it will try to create an improved plan. How OptaPlanner works, we are continuing. Then at 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 particular time, so if we are giving to this program say 30 seconds, you have 30 seconds, and inside that 30 seconds you calculate and figure out, or we can give it a 1 minute. So if we giving 1 minute, by 1 minute it will try to calculate, and the best solution it will find, it will keep that. So this is a final solution we have came up with. So say after final solution the solve or solver output is this optimized itinerary, where we are saying in morning museum time is 9:30 to 11:30, means we are asking that a visitor to visit museum from 9:30 to 11:30. Then we are asking that visitor to travel from 11:30 to 11:50 and reach to the park and visit park from 11:50 to 12:50. Then at 1 o'clock we are asking the traveler to have a lunch, and that lunch will be from 1 to 2. And then we are asking the traveler to again visit the observatory from that lunch place, and from 2:30 to 4 o'clock we are asking visitor to visit the observatory, and then asking that visitor to have her, means his or her dinner at 5 to 6. So this way we try to uh, respected all the constraints, at least all the hard constraints. We try to minimize the time travel, that is the soft constraints we try to minimize. And then we also try to have the preference, kept the preference. So he wanted to go to museum, so we also allowed that museum in our plan. So this is how OptaPlanner works. So this is the first part of the video. I hope now you all understood OptaPlanner. In our second part of the video, we'll be doing hands-on. We'll be writing a Spring Boot program, and we'll be seeing how OptaPlanner optimizing itinerary, and we'll be testing that through a Postman. So if you like this video, please like and subscribe my channel, and add some comments, means whatever, if you have any question, please put that in comment section. I'll be trying to reply those. And please share this video with your friends, and stay tuned for that next video, which will be the practical version of this OptaPlanner. Thank you. Thanks. Have a nice day ahead.